Okay, in this first segment on chapter 12, where we talk about sequences and series and summations and things like that, we're going to first define what a sequence is. And a sequence is, let me get a better pen, a function. And this function goes from the natural numbers to the real numbers. Basically, and we list it out. We talk about a function a of 1 being, say, the square root of 2. A of 2 being 3. A of 3 being minus 125. Right now, at the beginning, these numbers don't matter. I'm just defining the function. Except that we don't do, and obviously, then we just keep going 3, 4, 5, 6, 7, all the way to wherever we want to go. But we write these, instead of a of 1, we write it like a sub 1, and a sub 2, and a sub 3. So that we get a listing of numbers. Let me just let you see that for a little bit. We get a listing of numbers starting with, we have a definite first one, then we have a second one, and we have a third one. What the numbers are right now, you can see here, there's just no real pattern. Sometimes there is a pattern. Most of the times in this book, there is a pattern. But there is certainly an order. These numbers have an order. Square root of 2 comes first. 3 comes next. Negative 125 comes next. What comes after that? I don't know. It depends on what my function tells me. And my function may stop there. It may just say, that's it. That's all I'm doing. I'm only doing those 3. But this is that sequence right here. So, let's look at, here's the sequence right here. I'll start with 5. That's my first term. My second term is going to be negative 25. My third term is going to be positive 125. My fourth term is going to be negative 625. You probably see the pattern. Each time we multiply by 5. This is 5. The next one is 25. So I've gotten there by multiplying by 5. This is 125. That's 5 times 25. 625 is 5 times 125. But you notice the alternating signs. Positive, minus, positive, minus. Any idea what my next term would be? Well, let's see. What is 25 times 625? That's the first, 5 times 625 is 25 to 31. It's going to be 3125. That's my fifth term. Is it going to have a positive or a minus sign? Well, it looks like it's going to be positive, positive, minus, positive, minus, positive. We can come up with a definition for this. Notice how our first term is 5. Our second term is 5 squared, but we've got a minus sign on it. So what we could do is make a formula for that by putting a minus 1 in front and have it to the 2 minus 1 power. That way it will be odd. 2 minus 1 is 1. minus 1 to the first power is minus 1, and it'll work. This one, 5, is 5 to the first power, it's my first term, and it's to minus 1 to the 1 minus 1, or 0 power, so that's going to fix it. Let's see if it works from here. 125 is 5 cubed. If I put a minus 1 in it and do it to the 3 minus 1 power, that's going to be negative 1 squared, which is positive. So I think I've got a general formula, and I will now say my nth term, and that's what I call it. The nth term is 5 to the nth, and I'm going to put this positive and minus maker right here, n minus 1. That's a brief overview of the first thing about sequences we want to talk about. I have a little bit of time here. Let's now, nope, I'm going to save it for another video. Nth term, first term, second term, third term, fourth term. That's what sequences do. They are an ordering of numbers, and the order is important.